Okay, are we good to go? Awesome. So first of all, thank you so much. After lunch, seeing so many people in a session is always great. So hope we are all in for a nice session. So it's absolutely an honor and privilege to be here. So first of all, thanks again for joining for this session. So there is an old saying, right? Water, water everywhere, not a drop to drink. Somehow it's transitioned now to agents, agents everywhere. Everywhere you go, people are only talking about this. We did this agentic, we did that agentic. But sometimes the question is, do we really know what is an agent? And do we really know how to engineer an agentic system, right? This is becoming very, very pertinent, right? For instance, Microsoft back in 2 years back, now 2 years back is a long timeline, right? They introduced this AutoGen, right? That's when it all started, right? People started figuring out, okay, maybe I can have multiple agents coordinating and they can do some task. Then what happened, parallelly, everyone started coming up, right? Yesterday night, if you were awake, GPT-5 was released, and of course it was also some kind of agents on top of GPT-4, is what I felt, right? And then Microsoft came up with something, Google came up with something, and then we also have this news that goes around saying, oh, will my jobs be replaced? SaaS is dead, software services is dead. So there is a lot of questions that are coming up, right? So I'm not going to go to that hype because I understand there is a lot of hype, but I also want to touch upon the more real aspect, which is how do you engineer agentic AI systems? So my name is Karthik Vaidhyanathan. I'm an assistant professor at the Software Engineering Research Center, IIITH Hyderabad. And hopefully in the next 30-35 minutes, I'll be able to convince you that, yes, agents are great, but we also need to be mindful about how we engineer agentic AI systems. So a brief background about myself. Of course, I did my master's in software architecture, and I did another master's in AI. So somehow I ended up doing my PhD in the intersection of software engineering and AI, right? So that's where I come from, and of course, I also did a postdoc. All this was in Europe. So when I came back, when I was at least doing my PhD, this area was just getting spiced up, right? On one side, you have AI systems. On one side, you have software systems. So we were looking at how do you use AI to improve software architecture or software engineering practices. But then we started looking the other side. How do you engineer AI systems? Because someone needs to say about that as well. So my area is broadly in the intersection of this. And apart from that, the broad focus that we keep in our research is how do we be more mindful about sustainability, right? Everyone talks about agentic AI. Everyone talks about LLMs. Everyone talks about AI. But what is the impact of the softwares on the carbon footprint? What is the impact of the softwares on the energy that is being consumed? So that is where we come from. So that's a bit about my research. And of course, some fun facts. I'm a big cricket fanatic. So if you want to discuss about England versus India immediately after this talk, I'm all in, right? And also, I'm a movie buff waiting for the release of the Rajinikanth movie next week. And I'm from God's own country, Kerala. Yeah. So that's briefly about myself. Now let's go to the real part, right? So if you look at software systems over the years, they have evolved. When I say software systems have evolved, what I'm also trying to say is that the way we build softwares has also evolved, right? If you just take a simple example of an e-commerce system, that's a very simple, relatable example that we could all relate to. We were probably building it in okay, maybe not e-commerce in 1990s, but if you're building then, it was all considered as like one big block of code, everything into one piece. But then we realized, hey, you know what? Wait a minute, this is not working out well, because I cannot put everything in one piece because it's not reusable, it's not maintainable, it's becoming very difficult. So the question was, how do I break it down into modular pieces, right? And that's when service-oriented architecture came up. SOA came up, and everyone was like, okay, let's build services, let's put the services, anyone can use my services, I'll build authentications mechanisms around this, enterprise services buses came up, so all this came up. But wait a minute, no one knew how big or how small a service should be. It turns out that when Martin Fowler, one of the famous software architecture personalities, he went to one seminar and he asked, what is a microservice? Everyone in the room gave a different definition, right? What is a service? So no one knew what is a service. So then the question was, how do we define what is a service? Then slowly it started turning out, why do we not take adaptation from the domain-driven design? Can we say that every domain or every functionality becomes one service? It has its own data. And then we went into the microservice world of things. And then the question started coming up. Do I need all this 100 microservices so that all my joins can be over HTTP, right? Or should I reduce the number of services? How should I build them? And then also the question was, should I pay for all this? So cloud providers came back and said, hey, you know what? We will give you a better option. You just pay for how much time your function actually runs, break down your services into independent functions, and you can deploy a serverless, right? And then the trend has been going on. People are still with legacy systems and so on and so forth. On the other side, interestingly, the field of AI has also evolved over the years, right? When we say AI, today AI is very popular. Everyone talks about AI, right? It's become like a commodity, but the first thing came out in 1943 when two people, McCulloch and Pitts, came up with the first neural net. It's called the McCulloch-Pitts neural net, not the MCP protocol, but MCP neural net, right? That was the first ever artificial neural net that came in 1943. Ever since, a lot of developments happened over the years, right? Then came multi-layer perceptrons, multi-layer perceptrons. Then you had the recurrent neural network that powered your translations in Google Translate, LSTMs. So all this were coming up. But what happened over the years, the computing also started coming up, right? The amount of computing infrastructure that was available was growing higher, and the amount of data that was available was also growing higher. So this was all going in, and suddenly in 2017, boom, a big moment happened, right? And I'm sure everyone knows this. Right? Thanks to the paper, Attention is All You Need, although self-attention paper came in 2015, that paper introduced a new architecture called transformers. Because one of the fundamental limitations that previous architectures had is they couldn't create or store the relations between all the words to predict the next word. If I have to predict the next word in a given sentence, right, I should know the relation of all the previous words. As much as I know the previous part, I'll be able to predict better. So transformers came up with this concept that, hey, I'll allow you to understand all the relation between different words. All you have to do is throw in all the data you have and build a language model. So we had LLMs that came to the forefront. And then, of course, the rest is history. Different people started building different types of models on top of it, right? But what are we talking about? We are just talking about next word prediction. If I have a bunch of words, can I predict the next word with good confidence so that it feels like a sentence? Now, I keep doing that. What happens? You are generating a nice paragraph. Right? So this started becoming popular. People are like, oh, you know what? AGI is coming up. ASI is coming up. Yeah, all that is great. But ultimately, what you were doing is you are just trying to predict the next word. Right? And this started coming up. And on the other side, what happened? Then people started asking this question. If I can predict a sentence or a text, can I make the LLM to put out that text and also achieve a particular task for me? Right? For example, if I say, hey, how do I switch on my refrigerator? LLM will say, oh, you know what? Go here, turn on the switch. But if somehow I'm able to give access to the LLM to turn on the switch, it can automatically do that. This resulted in what is called as agents, right? If a model can be augmented with some more capabilities where it can perform tasks by itself, then we call it as an agent. And of course, then we had a lot of agent frameworks for AI agents coming up. Right, so a lot has happened, and we have also released, there are also a lot of bunch of leaderboards, right? There are different types of leaderboards you can go to and see what kind of model you want to use, what kind of agentic frameworks you want to use, and so on. But what is really an AI agent? What is really an agent? It's not that agent is a new concept in computer science, by the way, right? It's been there forever, right? It's just that people, that's what I'm saying, we are reinventing the wheel many times, yeah? It's been there forever. The concept is very simple. If I say, I want to book a ticket from Hyderabad to Bangalore, right? Previously, what I have to do, I have to go to make my trip or whatever. I'm not vouching for any websites, by the way, Clear Trip or whatever websites. You go there and you book the tickets, right? Now what we are asking is, can I have an agency do that? What is an agency? They know what they are doing, and they'll be able to achieve what they want to do, right? So now the question is, if an AI model has access to some kind of capabilities, right, by which it can leverage these capabilities to achieve a task autonomously by sensing the environment, then we call that is an AI agent. So the autonomous entity part is very important, right? Now, which means if I want to say, hey, I want to book a ticket from Hyderabad to Bangalore, I want the LLM to know, okay, it means that I have to find tickets for this particular person, but that is not enough. It should be able to go through these different websites, right, book the, put in the dates, identify the prices. It needs to know what Karthik as a person likes. Maybe I like non-stop flights, or maybe I want to be mindful about my budget. Maybe I prefer these kind of timings. Maybe I prefer this airlines. So all these preferences it needs to know. So it needs to have some kind of memory. It also needs to have some bunch of tools through which it can access these different websites and make these calls, perform this task, and say that, hey, I've booked the ticket for you. So that definitely you can call as an AI agent. By the way, I've put LLM agent because most of the AI agents that we are talking about today is all LLM agents. LLM is not AI, right? It's more generic. AI is more generic, right? It could be anything. But I'm just trying to give a relatable example, yeah? But this has a very much parallel to microservices. Now, if you look at what is the definition of a microservice, we simply say it's an autonomous service that can perform a functionality. It can interact with other services. Every service, by the golden rule of microservice, has its own database. Very similar, right? Every agent has its own memory. It can interact with other agents. Every service has its own database. It can interact with other services. I'm not saying that they are exactly the same. I'm just trying to give you a parallel so that you better understand this. Yeah. Now, let's break it down further, right? How did the evolution happen? So I'm just trying to take you through kind of a running example because doing a hands-on might be tricky, but I have a GitHub repo. I'll give you the link so that you can practice as well. So let's take some simple examples, right? All this was done using Gemini 2.5 Flash, right? So of course, you can go to Gemini website. You will get a key for free with some rate limits. So one of the easiest thing is something called reactive, right? One type of an agent per se is a reactive agent. What is a reactive agent? It just takes an input and outputs a kind of an action. It cannot do an action, but it just says this is a potential action you can do, right? Now, what is this? For example, if I say, give me a plan to do this presentation on Agentic AI, right? Gemini might come back and say, OK, let me craft you a plan, and it pulls all those things, right? Great. But now if I ask a question, hey, what was the recommendation of nasscom to startups in 2024? Now you get a very interesting result. It says, hey, you know what? I don't have access to real-time updates, or I don't have access to reports, because I was trained in 2023. I have only access to that data because I'm a model. I don't have access for more data. Now what do you do? The big part comes. Give some knowledge to the model, which is the external knowledge, or your organizational context. Of course, this you also call as RAG-based agents, right? What do? You just throw in a bunch of documents, and you say that, hey, when you answer, also look at this document and then generate an output for me. And now I can ask a question. I gave a report of nasscom, right? And it says, OK, now tell me what is the recommendation of nasscom to startups in 2024. It says, OK, the text describes that, OK, startups should probably start doing this and that, and a bunch of recommendations because it has access to data. Now, I can go further, right? So this is one step. I can do one more step and ask, what is the latest news of today? Right? Interesting. What does today mean to an LLM? Nothing. It's a model. Today is just a word for an LLM. It does not have the idea of the context. When I say today, I want the LLM to understand today means the 8th of August. It does not know this. So how do you make LLM know what is today? So you need to some way by which you can pass on this contextual information to LLM, and that is when tool-augmented agents come in, right? Where you give access to a bunch of tools. The moment you say today, can you make the system to call an API or call a function that returns the current date? Then it means that, OK, I know what is the date today. Now give that information to LLM so that LLM can generate a nice answer saying today's date is August this one. But I have asked the question about latest news. So what should I give? News API, right? I need to give some kind of a news, some way by which I can scrape out all the news information and then give it to the LLM and say, now give me the information of what is the latest news of today. Great, so that works, right? But there is one more question. You don't end up there, right? You go to ChatGPT or whatever tool, you keep asking questions, it somehow understands what you like and what you don't like. How is this happening? That is where memory comes in. So if you just go to a model and ask, OK, what is the date today? It now says, with the help of a tool, today's date is 8th August. Now I can ask, what did we just talk about? It'll suddenly start initially, if you don't have this concept of memory, it'll start saying, I don't know what we talked about now, because I don't have that information. So what do you need? You need some ability by which this agent can also store some past information about what interactions you had. This is where memory comes in. See, we humans, right? When you talk to your friend, you always have the context. Hey, I'm talking to this X person. I know what he likes or what she likes and what they don't like, and based on that, I change the topic. Right? This is because some part of our memory gets activated and some previous conversation. But when you're talking for the first person, you're all interacting with many new people here, right? You don't know each other. You're just trying to figure out what each of you are doing. And then you will create a memory footprint of that person. So next time you talk to them, you know better how to talk and what kind of things you are having in common and so on. So that memory. And there are different types of memory. There are memories like episodic memory, conversational memory, persistent memory, long-term memory, short-term memory. There are different types of memory. So when you're building an agentic AI system, you need to factor in what kind of memories you want for your use case, and you need to put in that. And of course, there are things like memGPT or memzeros that are actually playing a big role in creating these kind of platforms for storing memories through graphs and whatnot. Now we can go one more step further, right? Imagine that I want to complicate this. Okay? I know one agent can do all that. Now I want a bigger task to be achieved. right? For example, I mean, I did my PhD postdoc somewhere near Rome, beautiful city, yeah? So imagine that I am going to ask a question, hey, plan a trip to Rome. Now, plan a trip to Rome is just one query, but it has so many things attached to it. Because if you are planning a trip, you need to first understand, hey, what dates I want to travel, how much budget do I have, what kind of weather conditions should be there, what kind of things do I like to visit, right? And how much time do I have? All this needs to be factored in. And then finally, you might want to find some good, reliable airlines and so on and whatnot, right? So all this needs to be done. So how do you do that? Now what do you do? Okay, one agent is not enough. I probably need a bunch of agents because they are specialized tasks. You need some capability for budget planning. You need some capability for planning the overall trip. You need someone to review the plan. So you need specialized people who can do different things. That's what we do, right, in human way. Whenever you want to think of something of AI, first think how humans do that. That's the first thing we miss sometimes. We just offload everything to AI thinking it'll do magical stuff. So if you break it down, what we do, we just say that, okay, let me create multiple agents. Each of the agent has a role and responsibility, and I don't want them to do a haphazard interaction. I'll create an orchestrator, which will say, okay, first planner will create an initial plan. Budget will use some kind of calculations, understand how much money we have and all that. Go through all the websites, scrape the information, find the flight ticket price, and says that, okay, this is a good budget. Based on this budget, this is something you can do, based on the plan I've created. Then you go to the reviewer, which will review if everything is fine. And finally, a plan generator will probably book the ticket, send you an email saying that everything is done. And now, with this, I can create a nice plan that is coming up. By the way, this is all implemented, so you can go to that QR code, and you can see the GitHub repository. There is a Google Colab notebook. I made it like a Google Colab so that it's easy for you to consume. So you can just use that. You can inject your own API key from Gemini, and you'll be able to run through this example. Yeah. So this is great, but you might ask, okay, Karthik, what is the need for this orchestrator, right? Because this person is going to control everything. Can we go more dynamic? Right? So that is what we are talking about, a real multi-agent system, right? Where there is no orchestrator, every agent just keeps trying to talk to each other, right? So you can have different types of agent. It could be a reactive agent, it could be a tool-augmented agent or whatever, and they can all interact with each other without having a central orchestrator. So there is no one who is coordinating the flow. Now, this is again very similar if you go back in microservice patterns. There is a pattern called an orchestrator pattern, there is a choreography pattern. Orchestrator is when someone an orchestrator actually shows the waves, and based on that, the musicians play, right? In choreography, everyone are expected to know their moves, and they just dance together, right? Similarly, you can have a choreography as well. So here, every agent is just communicating. Blackboard just becomes a common place where you can just put in the messages. For people who are familiar with Blackboard pattern, this is inspired from that, yeah? And then I can again create a final itinerary. But the problem here is I don't have much control on the flow of it. I just expect agents to somehow figure out how to work together and come out with a response, with the magical stuff. This is very good in scenarios where you just want agents to dynamically discover other agents and perform actions. But this might not be always suited if you want to enforce stronger guardrails. Yeah? Great. So we also did a lot of research, right? Now going into some aspects of what we have been doing. So this is a basic ground of what an agentic system is all about. But there is also one aspect to it, which is communication, right? So if you look at agents, as I said, you can have multi-agents, you can have orchestrated agents, but how do they communicate with each other, right? Now, this agents has to communicate with tools. Tools are nothing but some kind of a function that you're writing, okay? But the problem is, if you write functions in whatever you want, so for example, if I say, hey, write me a nice API that will fetch the date of today, each one of you will write in your own ways, and you will say this is the best way. Right? Now, how will I ensure that the agent will understand that this is actually a date function and call that? How do I pass that context? That's when things like model context protocol came from Anthropic, saying this is becoming difficult because if I have so many amount of tools, how do I coordinate? How do I create something that is interoperable? This is again goes back to the problem of when internet came, what should be the common protocol by which computers can talk to each other, and we finally ended up with TCP/IP. So we need some kind of protocol by which agents can talk to tools. Similarly, we also need some kind of a protocol through which agents can talk to agents, right? That is when Google, they came up with this concept of A to A. How can one agent understand how should I invoke another agent? Because every agent will say, hey, this is a way by which you should invoke me. Every agent will have their own way. Now, how do you communicate with them? What kind of protocol should you follow? Can we standardize this? That is when A to A came, right? So these are a bunch of blocks, but again, this has parallel to microservices where one service wants to communicate with another service. Or one service wants to find which instance of service I should use. We use something called service discovery. Similarly, we need something called agent discovery, right? How do you discover agents? That is when you need these kind of protocols, yeah? Okay, so that's a bit of, concepts that builds into what is an agentic AI system. Now, going a little bit into what we have been doing, right? So we also understand that there are a lot of possibilities when kind of generative AI came in. So 2.5 years back, when LLMs were just coming into the forefront, we also started targeting some problems, especially in software architecture space, right? And one of the problems that I'm sure all of you would relate to is, I have a big code base, but I have no idea why did I write the code like that. Because the person who wrote it just went away from the company, and I don't know. And this is called knowledge vaporization, because why you did what you did, only that person knows. It's probably in the brain, right? It's not written anywhere, and we are all nice people who document everything, right? So how do you extract this document is always a question. Now, if I can do that, the benefit is, if I have a legacy system, at some point I'll be able to use this to modernize my system. Correct? So we started understanding, can we extract out architectural knowledge from code bases or from systems? So we performed, at that time it was only LLMs, yeah, I mean GPT-2 I'm talking about, yeah. So we said, can we use these different models to see if they are good? We also fine-tuned some models to generate architectural decisions, right? So we were looking at specifically something called ADR, or architectural decision records. And we observed that if you fine-tune smaller models, they can perform as closer to larger models that are outside, which is not in your on-prem, right? Which means it's a great importance for an organization, because I don't want to send my source code to a third party. So I can have a very fine-tuned model that can run within my on-prem, less cost, and it can perform equally good. Then we took one more notch further. We said, if I can generate decisions, can I also generate components? At that time, LLMs were generating, I'm saying at that time as if I'm talking about 2000s. I'm talking about like 1 year back, okay, 1.5 years back. That's the speed of technology updates that is happening. Yeah, so we were looking at, okay, can LLMs be used to generate components? LLMs were good at generating small pieces of code, but can I generate an entire component? And we tested with serverless functions. And we got very good result that LLMs were not really good. Okay? And it turns out that if you have a little bit of human intervention, they do amazingly well. Right? So the human architectural mindset with LLM support, we felt that it is creating a lot of support. Right? That time we also used something called DeepSeek 2.5. DeepSeek R was not released yet. Then we went next step. We said, okay, now this is great, but what about LLMs for helping my maintenance? Can I replace my site reliability engineer? With no offense meant, yeah? Okay? So we said, can we throw in a bunch of logs, metrics, traces to LLMs and ask it to figure out what to do in order to fix my system if it is running off an issue? Right? We tested just by using GPT-4, give out all the logs, traces, and everything, and said, hey, tell me what to do. And GPT-4 was suggesting some action. It was a little bit agentic, but we were implementing the action. Okay? There was a little bit of human in the loop. And then we observed that it was able to perform closer to the state-of-the-art benchmark in such kind of task. Not outperforming, but closer. Maybe today it's also better. Yeah? Then we went one more step further. We said, if we can do that, what if you can generate a system dynamically? For example, you have an initial system that is running. Suddenly, a user comes and says, hey, I want something, but the system does not have that. But can the system figure out what the user wants, create it, integrate it, deploy it, and give back the feature? That's what we were trying to do. Turns out we were not that great, but still good enough. Yeah, we did some user studies and so on, and people perceived that it was okay. But I feel that today, with all these capabilities, we are going there much faster. Yeah, so this was another work that was done also with some collaborators from Europe. So we have been doing a lot of works in generative AI for software engineering, right? Multiple parts, starting from requirements to development, deployment, and whatnot. Testing is something that we are slowly venturing into. So there are other faculties in the research center who are working in this. So this is all great, but you might ask, okay, Karthik, they are all nice, fancy research papers, but where is the real meat? Where is the real practice that is coming out of this? So at that point, when we were doing all this research, right, we were actually fortunate to be tying up with an organization, Monty Cloud. It's a startup just here in Bangalore, right? So they work in this area called autonomous cloud ops, right? So of course, we know that cloud is great. It provides a lot of services. But the problem is cloud also provides a lot of services. right? That sometimes we don't know what services exist, and also we don't know what are the different guardrails for different services. It might, I mean, you might suddenly discover that the cost is going higher, there are some security issues, and so on and so forth. So AWS or even Azure, they all come up with something called well-architected framework, which provides a bunch of guidelines, right, around which you can think of creating your cloud footprint so that it's maintaining the standards, right? And Monte Cloud is a company that comes and says, hey, we'll automate this whole task for you. We'll take care of these assessments. We'll tell you that your cloud footprint is good or bad. We'll tell you if there are some security issues. We'll tell you if there are some cost issues and so on, right? And they want to make it completely autonomous. So you don't need a person to do that, or with minimal human intervention, can the whole thing be done autonomously, right? So initially, we built a very simple Copilot, right? Copilot was a big thing at that point, right? Again, at that point. So we said, okay, let's build a Copilot. So we built a simple Copilot where a customer can come and ask, hey, tell me about my cloud footprint. Tell me how many instances do I have? How are my instances faring with respect to the cost, with respect to security? So all this, you will get nice answers, and it will also give you recommendations on what you could do. Right? So this was all great. So we felt, oh, wow, this is so nice. This was even before, I think, Amazon Q, for instance, right? But we discovered a lot of engineering challenges there, right? But again, many things of AI, right, as per Gartner stats, more than 50% of AI don't make it into production. They are all nice POCs in laptops and machines, but the moment you want to take it to production, everything starts failing, right? So we started discovering a lot of engineering challenges. Although it was in production, but we started discovering some engineering challenges behind the scenes. One is the distributed data problem. See, cloud has so many verticals within it, right? It has cost, it has security, it has reliability, performance, so on and so forth. So all these are different data, and you need different kind of expertise to look at different data, right? So this was becoming a challenge. Second, maintainability. We were using one kind of an LLM, and we were bombarding it with all the data, doing kind of racks. It was not working out well, right? Because we were having hallucination issues, we were having issues with not grounding on data, and so on. And then extensibility and modularity. We wanted teams within the organization to build their own things. But since everything is tied to one LLM, it was a very monolithic system. It was becoming very difficult for us to do this, right? And also the monolithic nature of the existing framework. At that point, we realized we probably need specialized people to do this. So Agentic thing was coming up, but at that time, Crew AI, LangGraph, all this was very monolithic in nature. You have to deploy everything in one place. But we wanted flexibility where we could deploy one in Crew, one in LangGraph, one in something else, and everything should talk to each other, right? This flexibility was not available. So what we do? We are researchers. We said, let's build it ourselves. Yeah? So we started thinking about multi-agent, so a use case can be something like this. So if you go to it and say, hey, improve the security score of my production application, it says, okay, let me first do a scan of it, understand what are the potential challenges here. Let me call some specialized tools like AWS Q or Microsoft Copilot, get some things, insights, and based on that, let me create a nice report which provides some kind of recommendations. Based on the recommendations, maybe I'll create some tickets saying that, hey, probably these are the high priority ones, these are the low priority ones in my Jira, and based on the tickets, let me go and perform the action. All this autonomously, right? So that was the goal. So we said, this is where we want to achieve. And what we did, of course, in collaboration with the company, is to build this framework that we call as MOYA, right? It's called Meta Orchestrator of Your Agents. So you can build an agentic framework in whatever framework you want. You can build an agentic system in whatever framework you want. You can use whatever models, but the idea is we can orchestrate it for you. And we open sourced it. Of course, the organization was kind enough to say that let's open source it. So we open sourced it. We also wrote a nice research paper out of it, right? And this paper was a best paper candidate for one of the top conferences in software engineering, right? So the basic idea was support custom agents in-house and orchestrate with guardrails. And the guardrails part was very important. We also added concepts like agent marketplace, because anyone should be able to add agents. The system should be able to incorporate the agents based on that. So you have some definition for agents, add it to an agent marketplace, and the orchestrator will take care of orchestrating it. So this is the basic architecture that comes up. So of course, you have all this nice UI, but the core engine has a bunch of agents that it has access to and a bunch of components, right? Now, if you look at components, of course, you have an orchestrator. You have some kind of memory that understands how the agents are interacting, what the preferences of the users and whatnot. Then you have different LLM processing units. But the most important aspect is an agent registry, where everyone can go and register the agents. We have now also extended with tools registry, so you can also register your own tools, right? And then you have a bunch of agents that are already there in the system that you could leverage. So you can add your own agents, you can use the existing agents, and you can build whatever use cases you want to build it for, right? So this was the basic idea. Of course, that is a repository, so you can go and check it out. As I said, it's open source. Feel free to contribute as well, right? I mean, you can send a pull request, and we'll be happy to consider that. So some agents in Moya, of course, we followed the principles of domain-driven design for people who are familiar with it, right? So we said, what are the different domains within the cloud, and what are the different domains we want to target? Based on that, let me identify my agents, right? So I had an agent for summary, so it creates a summary of my cloud footprint. I had an agent for creating, the reports, which goes through all my cloud, understands what are the problems, gives out the recommendations, creates a nice PDF that could be automatically sent to the customer every month or whatever, right? So this is all done, and now we are providing support for MCP, A2A. These are all on the way, so we are adding those kind of complaints so that people who are happy with MCP will also not get disappointed. So of course, we come from research side, so we don't want to just sell a framework and say this is great. Yeah? So we want to ground it, so we wanted to empirically show that they are able to perform well. So what we did is, we created a bunch of prompts. By the way, one of the challenges in this agentic AI systems is evaluation, right? How do you evaluate these systems? How do you put guardrails? So what we did is, we created a bunch of, like test cases, we created a bunch of prompts and the corresponding kind of responses we expect, and we tested with Moya as well as one without Moya. So we had a bunch of 260 prompts initially and some responses. And we observed that, of course, Moya was able to perform better in most of the times, and it got integrated into the product, and I'm sure some of the customers are actually using it. It is live. Yeah. So we didn't want to stop there. The organization said, OK, Karthik, we have built something, but let's make it open so that people can build different use cases, not just cloud operations, right? So what we did, we conducted a hackathon in IIIT Hyderabad, where we had 20+ teams with like 100 students. And we said that we also had a bunch of use cases that we want them to target. We also gave situations where they can also come up with their own use case, right? So they build different things. And we got feedbacks like the generalizability of Moya to any use case that you can use, ease of use. They also gave some suggestions for improvement. Of course, not everything is green, but we are trying to improve that. Of course, we also had some kind of press releases as part of the work that we have been doing, right? So if you have been listening so far thinking, OK, what is this guy talking about, right? After lunch, I'm sitting here, this guy is talking agents, memory, whatnot. If you are just waking up, these are some takeaways that I have for you, right? I believe that one of the key things is definitely, whether we like it or not, there is a small paradigm shift that is happening. Whether that is small or big, time will only tell, but there is definitely a paradigm shift that is happening in terms of how we are building software services or products. It's not that services are dead or services won't exist, but the way we build them will change, definitely change, right? So we need a change in mindset. That's the first thing. It cannot be that, hey, these are not going to do anything, why should I learn this? But instead, start embracing it and start seeing like a partner or a co-pilot or whatever. I also feel there is going to be a lot of support for automation, right? Especially for modernization systems, right? This could be a big game changer. Observability, reliability, responsibility, security. These are key words we need to be mindful about. These are challenges that has not been addressed yet, right? Everyone talks about some agent ops, whatever, but still a lot of work needs to be done in this space, especially the security side of it. And I also believe domain-specific LLMs can be a way forward. You don't need LLMs to power agents. You can have SLMs, which are very domain-specific, powering respective agents, right? We have also observed this. Probably, I hope that, and we have also done some research on this, right? I feel that there is going to be need for better practices or processes to build systems, right? Now that the agents are there, and I feel very certainly there is going to be a lot more technical debt. If at all, we don't know how to manage it. AI is going to inculcate more technical debt. Every time a model changes, you have to version many things, you have to change many things, so be mindful about it. So agentic AI is going to reimagine autonomy, sustainability, and intelligence at scale. I want to put that focus on sustainability, because everyone talks about agents, everyone talks about AI, but please be mindful of the environmental impact of it. Please be mindful about the cost, because the number of interactions that the agents can have can be sometimes humongous, so be mindful about it. Before I conclude, I would like to thank the team that has been behind it, because whatever I am here, I'm speaking, bragging, all this is because of the work that we have been able to do as a research group. So there's a bunch of PhD students, master students, honor students who are working with me. So credits to them, mistakes are mine. Feel free to visit our group website, research group website, or even the research center website, Software Engineering Research Center at IIIT. So let's try to be mindful about what we do. Let's try to not reinvent the wheel. Let's be mindful of what we are trying to build. On that note, I leave you. Thank you so much for having me here again.